So we could do 12, but we're not going to. We could do 13, 14, and 15. We could do it, but we're not going to. Why? Because I didn't see any of those types of problems on the final. Okay, so we're just going to skip those on the homework. Yeah, 12, 13, 14, 15, we're not going to do it. I didn't see them on the final. We're not going to worry about them, even though they're still pretty easy to do. On a previous video, I already explained numbers 1 and 2 on WSP 9.5. So we're going to start with 3. Now, just like I explained on the previous video, it's really easy to solve these equations by factoring, splitting, and solving. But they want us to practice using the quadratic formula. So let's actually do that. Let's practice using the quadratic formula. So let's write down the quadratic formula. So there's the quadratic formula. We should all write it down, and we should all know how to use it. Now, what do I mean by how to use it? We need to replace the variables with parentheses. So we did this with the vertex formula. When we had x equals negative b over 2a, I kept telling you guys, rewrite it with parentheses instead of your variables. You're going to do the same thing here. So after you do that, let's identify our a value of 1, our b value of negative 4, and our c value of 6, and then plug in the appropriate values. So the b is negative 4, plug that in right there, also right here. The a value is 1, put that there. The c value is 6, a value is 1. Now, whenever you plug in your values, you need to start with the discriminant value. The discriminant is the value inside the square root, the b squared minus 4ac. So if we work on b squared, let me actually rewrite everything. So I just changed the minus to plus 4 right here, and I just multiplied 2 times 1 is 2. But let's work on this discriminant. This is the most important part right here. What is negative 4 squared?
16.
That's positive 16. Now, what about the rest? We have a minus 4 times 1 times 6. So technically, you could say 4 times 1 is 4. 4 times 6 is 24. And we have a minus sign there. Or you could have also said, oh, negative 4 times 1 is negative 4. Negative 4 times 6 is negative 24. Either way, you're going to end up with a minus 24 right there. Now, what is 16 minus 24? So that'd be negative 8. And when we rewrite the whole thing, 4 plus or minus the square root of negative 8 over 2, we already know that this is not going to have real answers. If we were to think about the graph, it's not going to cross the x-axis, right? This parabola that opens up with the pattern 1, 1, 2, 4, 3, 9 is above the x-axis. But for the sake of giving actual specific imaginary answers, let's simplify the square root of negative 8. Well, first of all, the negative sign in front is going to come outside as an I value. So you'd have an I out here, and then you'd have the square root of 8. And the square root of 8 is not, 8's not a perfect square number, but you could rewrite it as 4 times 2. That way you will have a perfect square number of 4. Let's not forget about the I that's on the outside. So I would have I times 2 times the square root of 2. Why I times 2? Because the square root of 4 is 2. There's no more square root right there. So what I'm going to do is arrange this thing, 2i square root of 2. And I'm going to replace this value with the square root of negative 8. So I will have 4 plus or minus 2i square root of 2 over 2. Now, because we have 3 items that are all divisible by 2, we might as well reduce the 4 by 2, that by 2, and that by 2. So if we reduce all by 2, we end up with 2 plus or minus I square root of 2 over 1, but I'm just going to leave it like that because you don't need it over 1. Now, I would accept this answer. I'm not sure if the back of the book wrote it as 2 plus or minus square root of 2i on the back, with the I on the back. What do you got? What is it on the answers? So, we just checked the answers and we realized that they don't want the specific imaginary answers. Ladies and gentlemen, this is Algebra 2, right? Algebra 2, you need to do that. Okay. I guess in this class, once we realize that there's a negative discriminant, we just say what?
Imaginary.
Imaginary, or no real answers, right? No real zeros, no real solutions. So, yeah, I did all that extra work for nothing. But this is what All this work over here is what you will do in Algebra 2 when you get there. Okay, I guess let's try number 4.
For each question.
Yeah, there's a lot of questions, a lot of practice. But we're not doing the ones with fractions or decimals. So, quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Notice that I put parentheses instead of the letters that I was actually saying. The a value is 1, the b value is negative 6, the c value is 7. So let's plug in negative 6 where the b's belong. Let's plug in the a value of 1 right there, and the c value of 7 in there. So working this out, we will have negative 6 squared, which is positive 36, and we'll have a negative 4 times 1, which is negative 4 times 7, that's a negative 28. And that is still inside the root. Again, that's called the discriminant, whatever's inside the square root. And out front, we have a positive 6. On the bottom, we have a positive 2. 36 take away 28 is 8. So we really have 6 plus or minus the square root of 8 over 2. Everybody with me? Now, it would be awesome if that square root of 8 was a square root of 9. That way we'd end up with 6 plus or minus 3 over 2, but it's not. So we could simplify the square root of 8, which we should. Let's take the square root of 8, and it's not a perfect square number. Let's rewrite it as 4 times 2. Let's split the square root. You'll have 2 square root of 2. So what we really have here is 6 plus or minus, instead of the square root of 8, we have 2 square root of 2, and it's still over 2. Now right here we do have 1, 2, 3 items that are all divisible by what? 2. By 2, so we're going to reduce this entire fraction, and it has to be all 3, guys. Like let's say this was a 5, you have a 6, a 5, and a 2, you can't divide them all by 2, so it has to be all 3 items, okay? So let's divide all of them by 2. This by 2 you'll get 3. This by 2 you'll get 1, which is unnecessary. That by 2 you'll get 1, which is unnecessary. So let me write the final answer. 3 plus or minus square root of 2 over 1. So I'm not going to write that. It's just my answer. 3 plus or minus square root of 2. Okay, guys. So on the back of the solution page, it gives a decimal approximation. I really want you guys to work with radicals, because on the final exam it does work with radicals. It doesn't give decimals, all right? So final exam doesn't give decimals. So I want you to work through the radicals and simplify the way I have been doing right here. That way it'll prepare you for the final, okay?
Will we still get it right if we do it your way?
Yeah, absolutely. This is the correct answer. I mean, as a matter of fact, the only difference between this answer, 3 plus minus 2 square root of 2, and the answer on the back is that they actually do this on the calculator. So on the calculator, if you go 3 plus the square root of 2, hit equal, it'll give you a decimal answer. And then you go 3 minus the square root of 2, hit equal, it'll give you the other decimal answer. But the final exam doesn't do that, so I'm going to stick to these radical form answers. I'm going to stick with the square roots. I'm not going to actually give decimal approximations. Number 5, know the quadratic formula? Know how to use the quadratic formula. So let's plug in our values. We have the a value of 2, the b value of 9, the c value of negative 5. So we have 9 right here, 9 right there. The a value is 2, goes right there and there. The c value is negative 5. So let's start with the discriminant. 9 squared is 81. And then we have negative 4 times 2, that's negative 8, times negative 5. That is positive 40. Yay? So let's rewrite everything else. We're still working on the inside of the square root. We're still working on that discriminant value, but I am rewriting everything else, and I might as well do the 2 times 2, which is 4. 81 plus 40 is 121. So we have negative 9 plus or minus the square root of 121 plus 4. What is the square root of 121?
11.
No more square root, right? And this is actually 2 answers. You have negative 9 plus 11 over 4, and you have negative 9 minus 11 over 4. So you get 2 answers from there. Let's find out what those answers are. So what's the negative 9 plus 11? And what's 2 over 4? 1/2. So that's one answer. And how about the other one? Negative 9 minus 11. Negative 20. And then divided by 4? Negative 5. So your two answers are positive half and negative 5. So listen up, guys. Number 6, you could do this question different ways. Now, this whole worksheet's about the quadratic formula. But since we are solving equations, we could do something, even though we're going to apply the quadratic formula to make it a little easier. Notice that all of these are divisible by 2. In other words, they have the GCF of 2. So you could technically divide everything by 2, right? You could divide this by 2, that by 2, this by 2, and that by 2, everything by 2, and have a new quadratic trinomial equation, x squared plus 6x plus 5 equals 0. Now, I know we can factor, split, and solve, but the whole purpose of this worksheet that you guys have is to work on the quadratic formula. So there's the quadratic formula, and we should know how to use it. We're going to replace all the variables with parentheses. And then after that, we're going to identify the new a value of 1, the new b value of 6, the new c value of 5. And we're going to solve this thing using the quadratic formula by plugging in those a, b, and c values. So b is 6, a is 1, c is 5, a is 1. And we always start by simplifying the inside of the square root, the discriminant value. So inside the square root, I have 6 squared, and 6 squared is 36. And then I have 4 times 1 is 4 times 5 is 20. So I really have minus 20, and that is still inside the square root. And I still have the plus or minus. I still have a negative 6 out here, and on the bottom I have a 2. So 36 take away 20 is 16. So let me rewrite it. Negative 6 plus or minus square root of 16 over 2. And we all should know that the square root of 16 is 4. Negative 6 plus or minus 4 over 2. And that plus or minus actually means two answers. The plus 4 and then the minus 4. So negative 6 plus 4 divided by 2. And also negative 6 minus 4 divided by 2. So if we do negative 6 plus 4, that's negative 2. And negative 2, let me write that down. Negative 2 divided by 2, the answer is negative 1. That is one answer. Amy, pay attention, please. Negative 6 minus 4 is negative 10. And negative 10 divided by 2 is negative 5. So we get two answers. Those are the two answers, negative 1, negative 5. Number 7, we cannot use the quadratic formula yet, because in order for you to use it, you need to have it in standard form set equal to 0. So we're going to add 12 first and add 12 over here. So our new equation will be 12x squared minus 9x plus 12 equals 0. Now that it's equal to 0, now we could use the quadratic formula. And of course, we're going to use parentheses, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And we're going to identify our a, b, and c values according to the new equation that's set equal to 0. A is 2, b is negative 9, c is 12. So we're plugging in negative 9 for b. We're plugging in a for 2. A down here is 2, and C is 12. So let's work this out. Negative 9 squared, you always start with the inside of the discriminant. I mean, then again, the minus minus, we know that changes to plus plus. But inside, we have negative 9 squared, that is 81. Let me show my work over here. 81. And then we have 4 times 2, which is 8. And then 8 times 12, which is 96. So that's a 96, but we have a minus sign between it, and that's still inside the square root. We do have a plus or minus right in front of it. We do have that 9 out there in the front, and we do have 4 on the bottom because 2 times 2 is 4. So we still need to work on this. 81, take away 96. It's negative 15. And let me rewrite everything. 9 plus or minus the square root. And it's still over 4. Now, at this point, I believe in the back on the solutions, what does it say? No real answers? Could you guys check on the back, please? It says no real solutions. Okay, so I guess we could stop right there. No real solutions. Okay, in Algebra 2, you're going to have to keep going where the negative really produces an imaginary value. So you'd have an I on the outside. And you would try to simplify the square to 15, but you can't. So the final answer in Algebra 2 will be 9 plus or minus I squared to 15, all divided by 4. But right here, once we recognize that there's a minus sign inside the radical, we know that's imaginary, so we just say that there are no real answers, no real solution. So again, the discriminant, the value inside the square root, if it's negative, that means that you're not going to have any real solutions. Visually, on a graph, that means that your parabola does not cross the x-axis. Number 8, we need to first get it set equal to 0. And I did that by subtracting 12 here and subtracting 12 over here. Now we could see our A, our B, our C values, and we could use the quadratic formula. And when we use it, we're going to replace everything with parentheses. So negative parenthesis plus or minus the square root of parenthesis squared minus 4 times parenthesis divided by 2 times parenthesis. So let's plug in our B value of negative 5. Plug in our A value of 2 and our C value of negative 12. Right? The A value is 2, the C value is negative 12. The A value on the bottom is a 2 that we're plugging in. The minus minus changes to plus plus. We begin with the exponent. Negative 5 squared, what is that? 25. So we still have the square root. And then let's go for 4 times 2 is 8. Or you could call it negative 4 if you want to include the negative sign. Negative 4 times 2 is negative 8 times negative 12. That would be a positive 96. Let me rewrite the rest. The plus or minus, the 5, the divided by 4, because 2 times 2 is 4. So let's continue on. 25 plus 96. So we get 121. And that is inside the square root. We still have the 5 plus or minus and the 4 on the bottom. Now the square root of 121, what is that? This is 11. So I really have 5 plus or minus 11 divided by 4. So the plus or minus provides us 2 different answers. We have 5 plus 11 divided by 4, and we also have 5 minus 11 divided by 4. So 5 plus 11 is 16. 16 divided by 4 is 4. And 5 minus 11, that's negative 6 divided by 4. That is negative 3/2 if you reduce it, or negative 1.5. So the 2 answers are 4 and negative 1.5, negative 1.5, or you could leave it negative 3/2. It's totally up to you. But those are our 2 answers to that problem. So let's begin by writing the quadratic formula down on number 9. There's a quadratic formula, and then we need to replace the variables with parentheses. And then we need to identify our A, B, and C values. Now here's the problem, guys. You cannot identify A, B, and C unless it's set equal to 0. So what we need to do is get rid of that 4 by subtracting 4 and subtracting 4. So we need to rewrite the quadratic trinomial equation. Here it is. 3x squared plus x minus 4 equals 0. And now that it's in standard form with everything to one side set equal to 0, now we could look for A, B, and C, where the B value is 1, the C value is negative 4, and the A value is 3. So let's plug in our values. The 1 is B, so plug it into those parentheses. The A value is 3, so it goes into these parentheses. And the C value is negative 4, so it goes into that last parenthesis. Now, whenever you're using the quadratic formula, I recommend always starting with the discriminant value, which is the value inside the square root. So we have 1 squared, that's just 1. And then we have negative 4, I'm including that negative sign. So negative 4 times 3 is negative 12 times negative 4, that's positive 48. So inside this square root, we have a positive, actually, we have a 1 with a positive 48. You guys agree? The 1 came from the 1 squared, and the 4 times 3 times 4 is 48, and a negative times a negative is a positive. And we still have it over 6. We still have a plus minus in front of the root, and we still have a minus 1 out here in the front. So 1 plus 48 is 49, so let me rewrite everything. There it is, negative 1 plus or minus the square root of 49 over 6. And we should all know that the square root of 49 is 7. So we have 1 plus or minus 7 over 6. And then from there, we actually get two answers. We have negative 1 plus 7 divided by 6. And we also have negative 1 minus 7 divided by 6.
So it'll be 1.
So on the left side, negative 1 plus 6, or negative 1 plus 7, that's 6 over 6, which is 1. That's one answer. On the other one, we have negative 8 over 6,
which is 4 over 2.
which you could reduce by 2, and it'll be negative 4 over 3. So that would be the answer for number 9. Both of those answers, 1 and negative 4/3. Let's practice some more. So similar to number 9, it's not set equal to 0. So let's do that first before writing out the quadratic formula. Plus 8x plus 8x. You can't really add it. You're just going to rewrite it all. And of course, now you could actually identify A, B, and C, where A is 3, B is 8, and C is negative 1. And I could write the quadratic formula again, but just to save some time and space, I'm just going to do the parentheses. So let's go negative b, negative parenthesis, plus or minus the square root of b squared, parenthesis squared, minus 4 times a times c, all divided by 2 times a. And of course, that'll be your answers. X equals those answers. So let's plug in the b value of 8. Let's plug in the a value of 3, the c value of negative 1, the a value of 3. And let's work on the discriminant value. 8 squared is 64. 4 times 3 is 12, times 1 is 12. A negative times a negative. Why am I saying negative times a negative? There's a minus here and a negative there. A negative times a negative is a positive. So I really have plus 12. So I have 64 plus 12 inside the root. I have the plus minus on the outside, a negative 8 in the front, divided by 6 on the bottom. So what we really have is 76 inside the radical value. So let's rewrite up here, negative 8 plus or minus the square root of 76 divided by 6. So what we should try to do is simplify 76, the square root of 76. So 76 divided by 4, you could do that on a calculator. 76 divided by 4 is 19. So I could rewrite 76 as 4 times 19. So 76 is not a perfect square number, but if you rewrite it with 4, now 4 is a perfect square number, so you could split those roots, and the square root of 4 is 2, and the square root of 19 is going to stay square root of 19. So the 2 square root of 19 is really the same thing as the square root of 76. So the next step would be to replace the square root of 76 with 2 square root of 19. So you will end up with negative 8 plus or minus 2 square root of 19, all divided by 6. Now, this is the answer. However, we could reduce it. This is probably one of the mistakes that most students make. They forget to reduce. If you do have 3 terms, the 8, the 2, and the 6, and it's all divisible by a number, you should reduce it, right? If you have a fraction 4/8, you're not going to leave it 4/8. You're going to reduce it to 1/2. So the 8, the 2, and the 6 could all be reduced by 2. So if you reduce by 2, you're going to get a 4, a negative 4. Reduced by 2, it'll be a 1, which is unnecessary. Reduced by 2, you have a 3 on the bottom. So your final answer should be negative 4 plus or minus square root of 19, the 1 is not necessary, divided by 3. Now, ladies and gentlemen, if you look at the back side of your worksheet, the solution will not look like that because the instructions say to give a decimal approximation, right? But I'm letting you know right now that the final exam has these types of answers in radical form, not as decimals. So I'd like to see you be able to get to this answer. Number 11, let's get 15 to the other side to make it equal 0. Let's rewrite everything. Now that it's in standard form, you could identify A, which is 4, B, which is 7, and C, which is negative 15. We need to know that quadratic formula, and we need to know how to use it. Let's replace the parentheses, or replace the variables with parentheses. So the B value is 7. Let me do it in red. 7. 7 right there. The A value is 4. C value is negative 15. The A value is 4. Let's work this out, starting with the discriminant 7 squared, that's 49. And And we have negative 4 times 4, that's negative 16. And negative 16 times negative 15. So we end up with 240. And that's still inside the square root. We still have a plus minus in front and a negative 7 way out in the front divided by 8. So we really have negative 7 plus or minus the square root of 289. And with the calculator, hopefully we could do the square root of 289, which it does work. It's 17. With the calculator, if you go 289, square root that, it's 17. However, it's still over 8. So let me rewrite the whole thing. Negative 7 plus or minus, we said the square root of 289 is 17 divided by 8. So this is going to provide us two separate answers. We have the negative 7 plus 17, and we also have the negative 7 minus 17. And of course, we need to divide by 8, both of them. So we end up with 10 over 8. That's one answer, but it could still be reduced. So 10 over 8 reduced by 2 becomes 5 over 4. That's one answer. And the other one is negative 24 over 8. Negative 24 over 8. And negative 24 over 8 is negative 3. So your two answers are negative 3 and 5/4. So ladies and gentlemen, we're not supposed to do the rest of these 12, 13, 14, and 15. You could skip because those have decimals and fractions. Not that it's not important, but I don't see them on the final. So we're pretty much just focusing on the final. Now, the second half of this homework, we still need to do the second half. The second half of the homework is just focusing on the discriminant. I'll explain that on a different video.